Welcome back. I can't believe that we've reached the last of that incredible journey, and sure we've learned so much and had a lot of from today. Past few days, we have had fantastic sessions, hands-on training. Considering new final session, the 5-day faculty digital image processing using Matlab, organized by Institute for Engineering Research and Education, ICT, in association with the academic partner, PES Institute of Technology and Management, Shivamoga. Now, Dr. J. Shomasekar will be sharing his insights on digital image processing using Matlab. With his extensive knowledge and experience, we have no doubt that this presentation will be informative, engaging, and thought-provoking. We'll also be answering some of the questions at the end of the session. Please feel free to submit your questions using the question answer function at any time during the presentation. So, without further ado, please join me in welcoming Dr. J. Shomasekar to take the session. Over to you, sir.
Thank you, ma'am. Whether my slides are visible, madam, full screen. Hello. Okay. Okay, sir. Thank you, Praveen, sir, for response. Good evening, all the participants. Hope my slides are visible and I'm audible properly. So once again, welcome to 5 days FDP on digital image processing using Matlab. So good evening to all the participants. So coming to day 5 session of the FDP. So far we have completed 4 days. So from first day introduction with hands-on of basics of Matlab. Second day some smoothing filters with hands-on. So third day continuation of that smoothing filters with enhancement techniques of contrast for betterment of the images quality. And yesterday also we have continued with the histogram equalization with hands-on session. And now we will go for continuation along with some of the segmentation techniques and other concepts with research directions we'll try to complete in today's session. So of course, just I'm showing the roadmap for the image processing using Matlab. By using that, we can explore or we can enhance further concepts of the image processing. So hope it is helpful to you, because it's not possible to complete entire image processing or Matlab within 5 day sessions, because even if you take our semesters also, around I used to take 50 to 60 hours image processing. So that many hours we require to complete not entire image processing as per the syllabus of our university. So coming to fifth day, we will see some of the concepts that is extension of previous session. So when you come to the contrast enhancement, so we have histogram processing techniques. So far we have completed histogram equalization. That is very, very simple and basic contrast enhancement technique. Yesterday class we have completed what is the algorithm and how to implement for the histogram equalization for the given images with Matlab hands-on we discussed, and also numeric examples also I have explained how to apply histogram equalization for the given input image. If you have an input image, how to apply histogram equalization, based on that what type of output we will get. So that we discussed in detail yesterday's session for RGB images as well as grayscale images. Matlab execution we have done. And we have histogram matching is left. These are all very simple things we'll try to complete. And histogram specification, we can call it as histogram matching or histogram specification. And histogram sliding, just we have only one formula for this histogram sliding. And histogram stretching, this also only one formula we have. So that histogram processing techniques for contrast enhancement. And by using that, maybe we can go for other type of techniques for contrast enhancement we can apply. So even CLA, HE, all those things also available. But basic things, these are the contrast enhancement for the given RGB images or grayscale images. So histogram equalization, basically idea is whenever we take an input image, So we have an input image. This is the histogram. We know what is the meaning of histogram, and with the Matlab code, everything we have completed previous sessions. So this is the histogram, and here most of the pixels are clustered here. And when you go for equalization, all the pixel values are equalized here. Based on that, we can look for better contrast. So that we have done complete examples and hands on everything in previous session. So no need to go for once again. So next one is a histogram sliding. This is also very simple concept. Whatever input image we have, just we have to add, we have to subtract. When you add something, we'll get more brightness. When you subtract something, we get less brightness. The basic formula is like this. So input image is f of xy. The output image after applying histogram sliding, g of xy equal to f of xy plus some threshold value. We can call it as offset value. So we can call it as offset. So it is offset is positive or negative. If we add offset is positive value, then you will get more brightness. If you add offset value is negative, then you will get less brightness. So that's why let us assume T is offset value or threshold value, whatever it may be. So this is called histogram sliding. So we have to make slide either right side or left side, but this is not at all encourageable technique for contrast enhancement. But this is also one of the histogram processing technique. Anyhow, that examples I will show later. I'm giving the brief idea. And next one is histogram stretching. So histogram stretching means, let us assume the student marks is distributed from 0 to 50, let us assume. So I have to stretch from 0 to 99 or 0 to 100. Maybe student marks are 50 to 70. All the student marks lies between 50 to 70. Instead of that, I want to stretch from 0 to 100. So this is called histogram stretching. So whatever range we have histogram intensity values or pixel values, that I have to stretch a little bit more. That is called histogram stretching. So anyhow, this we'll discuss in detail through Matlab, maybe through numeric example and algorithm formula only. This is the input histogram. I have to stretch, then you'll get like this. So 0 to 255. All the intensity values are lies between 0 to 255 instead of 50 to 100. Let us assume here the intensity values are lies between 50 to 60. Now here 0 to 255. Just I want to stretch the histogram. All the values are distributed here, intensity values are. So that is called histogram stretching. That formula I will show later. And here also you can see, so 84 to 153, the intensity values lies between, after histogram stretched, the values lies between 0 to 255. So that the intensity values are distributed across the intensity range like 0 to 255, we can find little bit better contrast when compared to the input image. So this is also one of the simple histogram stretching technique for contrast enhancement. But here also we have simple formula like what we have discussed for histogram sliding formula. And one more important thing is histogram matching, or we can call it as histogram specification. So here, so this is the what we can call it as a input image, and this is the reference image, and by using that reference we have to make it as a output image. So what does it mean here? I will explain in detail what is histogram matching. So let us assume the student marks are 50 to 60. Let us assume this is the student marks. Now I am giving target, so up to 90. Let us assume, so 50 to 90. I'm giving target is 50. This is called target image or reference image. So this is the input image. This is the target image. With the help of reference image or target image, I have to make 50 to 60. Instead of that, I can make it as a 50 to 90. So that the contrast is increased. That means the contrast is distributed up to 255, but here up to 90. So that the contrast of the input image will increase. So that is the concept of histogram matching. Just we have input image and we have target image, or we can call it as a reference image. After that, applying algorithm, so we have to make the output image is 50 to 90 or 50 to 100, let us like this. So we have to go for reference image. Based on that, we have to display output image. There we can get better contrast. So that is the concept of histogram matching, and you can see the here. This is the reference image. The reference image values are distributed like this, and this is the target image. When you see the matched image, output image, all the values are distributed across 255 like this. Anyhow, through example with Matlab code, everything I'll explain for this. Just like summary, and I will explain all those things in detail. So this we have completed yesterday's section, histogram equalization and input image, output image. So before histogram equalization, after histogram equalization, So equalize the intensity values. That's why we can able to see better contrast. And MATLAB code also we have completed yesterday's session with hands-on. Just we have to use the function hist eq. So that means hist equalization. So that is a simple MATLAB function. If you go for Scilab, im hist equal. So when you go, if you are looking for Scilab code, same concept, but the function is different. The function or library is different. Im hist equal. So this is the Scilab function, but here we are looking for MATLAB, just hist eq within bracket input image. So that we discussed yesterday with hands-on also. And even for color images also we have completed how to go for histogram equalization for color images. What we have done yesterday, so we have completed histogram equalization for each channel, that is called red, green, blue. After that we have to merge the three channels. We'll get original image with contrast enhancement for the RGB or color. This is the input image and this is the output image for the color histogram equalization. And MATLAB code also we discussed. So we have to apply histogram equalization for, so R, GB, all the three channels we have to apply histogram equalization. After that we have to go for concatenate. That means we have to merge all the three channels by using cat function, and the resultant value is imshow. So that will get output. So even we have discussed all these input output images, original image, color images after contrast. So up to here we discussed with hands-on, with complete algorithms, all those things in yesterday and previous sessions. And now we'll go for one more simple algorithm that is called histogram specification or histogram matching algorithm. So here I already mentioned we have two images. One is original image. Let us assume A is the original image and R is the reference image, that is called target image. And first we have to apply histogram equalization for A. That's what we have done so far. And after that we have to apply histogram equalization for R. We know clearly what is histogram equalization for contrast enhancement with algorithm, numeric example, MATLAB code execution for gray level and color images. We have discussed in detail so many examples. Now we have to apply histogram equalization for A, or that means input image as well as target image or reference image. After that we have to go for invert transformation like this. So S equal to T2 inverse T of T1 R. You can understand, for example, what is it mean. So let us assume, so after applying histogram equalization for input image, so gray level values are 0, 1, 2, let us assume. And after applying histogram equalization, the values are, let us assume, so 1, 2, 3. After applying histogram equalization here, let us assume 0, 1, 3. So what is the meaning here? So T1 or means the transformation for histogram equalization of the original image. That means 0 to 1 is mapped. Now 1 is mapped to reverse direction. So 1 is mapped to T2. So 1 is close to 0, not possible, both are equal. Now T2 inverse, which is mapped to 1. So therefore wherever 0 we have to replace it. That is the meaning. Anyhow, through numeric example I'll explain clearly what is the meaning of this formula. Means first we have to go for transformation 0 to 1, then 1 is close to 0. That is not correct because 1 equal to 1. So that reverse transformation T2 inverse. So what is T2 inverse? 1. So therefore the corresponding gray level value is 1. That means wherever 0 we have to replace 1. That is the meaning. But anyhow, with the numeric example, I'll explain in detail about this algorithm, whatever I have displayed 3 steps. It's very simple. If you know histogram equalization, so same thing, almost 80%, only 20%. The transformation is the different. Rest of the things we can apply as it is what we have done so far. So this is the simple algorithm for histogram specification, or we can call it as a histogram matching. So suppose if we take a sample, this is the input image or source, and this is the target image, or we can call it as a reference image. After applying histogram matching, matched image, you can see input output, you can find some difference. So you can see the color of the cat, you can see input image, and based on the reference image the color changed here. So that means the target is more. Here the input pixel is 50, let us assume. Here reference the input pixel is 170. In the matched image the input pixel value changed to 170, like that. So that because we are using reference, so I am taking reference as a topper of the country for GATE exam. By using that I'm preparing for GATE exam. Maybe I will get all India rank first or maybe second next GATE exam, like that. So that means I'm taking motivation. Based on that I have to put effort. Same thing here also. We have to take motivation, or we have to consider it as a reference of this image. By using that, this intensity values we have to change it to 170 or 150 here to that value. so that the output image also changes. That's why in the matched image also we are able to see the color properly. So this is a simple example, but still we don't know how to apply. So just I'm showing the input output, what is exactly going to happen after applying histogram matching. Now based on this, we will see numeric example. After that, Matlab. Matlab code no need to worry because all are standard functions, because already we are installed image processing toolbox. All the functions are available. That's why no need to worry about that one. The code what we are going to write, because just we have to use the function. So directly we can execute the program. Like in Java also, if we have any package, predefined package, just we have to import that package, we can execute directly. Like that, we can save the time also. Suppose if you want to write code, then it will take a lot of time. It is not that much easy to write code for histogram equalization matching, or maybe other thresholding techniques, etc. So the advantage of this Matlab is this one, libraries. So based on that function, directly we can implement and we'll get output also. So this is the one more graphical representation. So this is the input histogram. This is the specified histogram. So input histogram, we can see you are able to see the intensity values. So, and the target histogram, that means reference histogram, you can see all the intensity values are very high. So that's why by taking, that means the, let us assume he is the average student and he is the topper. So the average student to take it reference as a target, I mean topper, then you will increase the, you will improve the marks. That is the meaning here. So this is the input image histogram. This is the target image histogram. After applying histogram matching, so we can find the input image histogram intensity values are increased, so that we can find matched image. That is called output image with contrast enhancement. So this is a simple thing. What we are going to focus on histogram matching or histogram specification. So when you take numeric example similar to histogram equalization, so we have a input image, gray levels and number of pixels. We have a target histogram with gray levels, number of pixels. What does it mean? Zero level, where in the input image, wherever gray level 0, how many pixels we have? 8 pixels. So in input image, gray level value having 10 pixels. That means frequency is 10. Input image, gray level value 2, pixel value is 10. Input image, gray level value 3, input pixels 2. Input, I mean, gray level 4 and number of pixels 12. So like that, the information is given for the histogram specification or matching. After that, the target histogram values also specified given. So gray values and number of pixels we have. As you can see here, gray level starts from 4. Rest of the gray level values no pixels only. That's why we are taking reference image as a target image. By using that, we are going to look for contrast enhancement of the input image. So step 1, which is similar to what we have applied in yesterday's session, histogram equalization for the input image. We know how to apply histogram equalization for the input image. So I don't want to explain once again in detail, because just you can go through yesterday class recording session. You can find complete details about what is histogram equalization for the input image. So gray levels, number of pixels, and find the probability density probability, and find CDF and make a transformation L-1 into CDF and round off. This is called histogram equalization steps that we discussed yesterday class. So if any doubt also, you can put a message in the chat box. I'll explain once again also, but already we discussed. That's why no need to waste time for discussion of this once again. So just we have just we have to complete step 1, histogram equalization for original image. Step 2 is histogram equalization for a target image. Sorry, that is called reference image. We can call it as reference image. Here also same procedure. So this is given already in the question itself. Find the probability and find the cumulative distribution function, and L-1 into this, find the round off. Now, so finally, we found two things. One is from histogram equalization for the original image, we have gray level values and round off. That is the transformation SK. And from target image, gray level values on round off. That is called Z-tip. That is the transformation. What is the meaning here? Transformation. So wherever 4, we have to replace 2. Wherever 5, we have to replace 4. Wherever 6, we have to replace 6. Wherever 7, we have to replace 7. That is the meaning here. In input also. So wherever 0, we have to replace 1. Wherever 2, we have to replace 3. Wherever 3, we have to replace 3 in the input image. That is the meaning. So that we discussed also already. Now, when you come to the final step, so gray level values, this we have calculated in step 1, histogram equalization for original image, and step 2, we calculated for histogram equalization for a specified image or a target image or reference image. Now we have to go for mapping. That mapping formula I given in the algorithm, S equal to T2 inverse T1 of R. So this is the formula I have given in the algorithm. You can check it in the previous slides. So first step is we have to find histogram equalization for the original image. In second step, we have to calculate histogram equalization for the target or reference image. And last step, we have to do transformation, that is T2 inverse into T1 R. So what does it mean? I'll explain. So here you can see 0 is mapped to 1 in the histogram equalization of the original image. Next, we have to see whether 1 is available in the histogram equalization of specified image. No. So if 1 is not available, next value. So what is next value here? 2. So next value is 2, and this is the transformation, and T2 inverse, this is mapped to 4. So that means, so wherever 0 we have to replace by 4. That is the meaning. That means, so 0 is replaced by 4. 0 is replaced by 4. So once again I'll tell you. So here first 0 to 1 mapping in the histogram equalization of the original image. Next, we have to look for whether 1 is available in the histogram equalization for target image. If not, next value. So here 0, no need to consider, no need to consider, no need to consider, no need to consider 2. So we can consider. So 2 is better than 1 or equal to 1, we can consider, but 1 is not available, so we can consider 2. So this transformation is done. So T1 of R, this transformation is done. Now T1 of R, we have one more transformation that is called inverse. So T2 inverse. So these two corresponding to which gray level value? 4. So therefore, so 0 is mapped to 4. That means wherever 0 is available in the input image, we have to replace with 4. So that is the point. Similarly, I hope this you understood the formula what I have discussed. S equal to 2 to T2 inverse of T1 or like that. So next, so 1 is mapped to 2. Now we have to look for 2 or more than 2. So 0, not, no need to consider, no need to consider, no need to consider, no need to consider, but 2 is available. So again 2 is mapped to 4. So that's why here 4. That means 1 is mapped to 4. Wherever 1 replaced by 4. Next, 2 is mapped to 3. There is no 3, no 3, no 3, no 3, or more than 3, no 3, but more than 3 is available. So we can make it as a map, that is called T1 of R. And inverse, inverse is nothing but 5. So that means wherever 2, we have to make it as a 5. So that is the next. Similarly, 3 to 3 and 3 to 4 inverse 5. So that's why replaced by 5. Wherever 3, replaced by 5. So this is the way we have to make a mapping. That is the final step. Hence, so wherever 0, replace 4. Wherever 1, replace with 4. Wherever 2, replace with 5. Wherever 3, that means you can see there is a huge difference in the intensity value changes in the mapping. So when you go for histogram equalization, the changes are happening only 1 or 2 points. But when you go for histogram matching, the output values, the mapping is 0 to 4 instead of 0 to 1, 0 to 4, instead of 1 to 2, 1 to 4, instead of 2 to 3, 2 to 5. So the intensity values are drastically increasing. Because of that reason, we can find better contrast when compared to the previous technique. So that's why finally, so we have to go for mapping 0 to 4 and 1 to 4 and 7 to 7 like this. So this is the final step of histogram stretching. So hope we understood what is the meaning of histogram, matching or specification. Suppose the input image looks like this. Suppose I'm taking, just for understanding, I'm taking 2 by 2 matrix 0, 1, 1, 2. So this is the input image. After applying histogram matching, so what is the output here? Output image here, the output image looks like this. So wherever 0, we have to replace by 4. So wherever 0, we have to replace by 4. That's by 4. Wherever 1, we have to replace by 4. So that's why here 4. Wherever 1, again we have to replace by 4. 4. Wherever 2, we have to replace by 5. So 5. So this is the input image, this is the output image. You can see the drastic variation in the intensity pixel values. So this is called, because I am fixing target is the student already got 50 marks. Next semester I am giving target 100. So that means based on the target, he has to put efforts. Then obviously he may reach 90 or 95, maybe 100. Same thing here also. That is the concept. Because I am giving reference image or target image, because of that reason, the intensity value is having drastic variation in the output image. So this is called histogram matching or histogram specification. So hope you understood the numeric example. We will see hands-on by using MATLAB, but the function is very simple. Just we have to use Hist match. That is the simple MATLAB function we are going to use. Whatever process we discussed, so we are going to use simple, but the entire code is available in the MATLAB tool. Yeah, Hist match function. So, but here we are going to use just MATLAB function Hist match. We have two parameters. One is input image, one is reference image, and we can display the output image. We will see that one in detailed MATLAB hands-on also. So here also similar example. So we have input image after histogram equalization. So this is the histogram equalized intensity values. Again, this is target image equalized histogram equalization. Then after that mapping, just now I told what is the mapping here. So 0 to 4 and 4 to 0 and 0 to 1 to 9 and like this we have already done just now. What is the meaning also we discussed already. So finally we'll get output image. So this, if you want, you can go through carefully what we have applied for the previous example, we can find. So what does it mean here? 0 is mapped to 4. So here 4 is mapped to 0, reverse T2 inverse. That's why here we are getting 0. So like that we have discussed previous example also. So coming to the, hope you understood that clearly what is histogram specification matching. Now we will see MATLAB function for histogram matching hands-on. So I already mentioned, so we can go for very simple MATLAB function that is called Hist match. So adjust histogram of an image to match histogram of reference image. So that is the objective what we have discussed so far. So just we have to apply the function that is called Hist match, and we have two parameters. One is input image and one is target image, that is called reference image. So anyhow, input image we know and reference image we know. So based on that, we have to go for histogram matching, the algorithm what we have applied, and the output image is stored in the variable b. So just you can use display, im show b, you will get output. You can see the MATLAB code. So and imread original image and imread reference image. We have to read two images. So one is original image, one is reference image. Next we have to go for Hist match. So we have to go for histogram matching by using the MATLAB function that is called Hist match. So we have two parameters. One parameter is original image, one parameter is reference image or target image. Now just display B, the resultant enhanced image stored in the variable B, you will get output image. I have displayed original image by using subplot. So we know what is the meaning of subplot, intro, all those things. We have already completed these things in the first and second sections only. And finally you'll get output image. Now you can see the original image, so too dark. So you can, as you can observe that original image too dark and reference or target image having little bit brightness. After applying histogram matching, we can find brightness for the original image. So that is the enhanced image after applying histogram matching. You can see the enhanced image is better than target image after applying to the original image histogram matching. We are able to see enhanced image properly. Here also you can see, so this is the input image and this is the target image, reference image, and as you can see the histogram matched image, that is the output image after contrast enhancement. So based on the target image only, you will get output. If the target image is not up to the mark, then you can't find better. That's why the reference. So whenever if I'm taking any reference for my exam, that person should have better than my percentage. Then only I can consider it as a target or reference. If he's having less than my percent, what's the need of considering as a reference or target or maybe motivation? So because of that reason, always the target image should be proper contrast. Then only we can apply the target image as reference image while applying the MATLAB function. So, and histogram sliding, anyhow, that hands-on I will execute now only. So I will try to complete this histogram sliding also. That is very, very simple. So here, very simple, what we have to do, just we have input image, just add some value. So that is called offset value. If offset value is positive, then we can find brightness overall the image. If offset value is negative, then we can find dark image. Suppose if offset value is, let us assume 50 for in each pixel, maybe you can find little bit brightness. Suppose if we take minus 50, we can find dark. So that's why, so this is one of the simple technique. What is histogram sliding? We can go for sliding either left side or right side. Left side, if you want to make sliding in the histogram, we have to subtract. Right side means we have to add. That is called offset value or some threshold value, let us assume. So this is called histogram sliding. So here you can see the example. So gxy equal to fxy plus 50. Just I'm adding 50 for the input image. So that the old image and after new image we are able to, that 50 is distributed entire image, each pixel value added by 50. Based on that we can find the output image. So old image, new image, and old histogram and new histogram. So we are able to find the distribution of the pixel value across the input image. So this is very simple technique. It's not that much good for contrast enhancement, but this is also one of the simple histogram sliding. By using that, we can enhance the contrast of the input image. And histogram stretching. So in histogram stretching, so we can go for this formula that is called transformation. Input value is transformation to output. So g of xy equal to input pixel value and minimum input pixel value and maximum input image pixel value and minimum input pixel value and maximum value of the grayscale. If we take 8-bit image, 255 is the maximum, 0 is the minimum, plus minimum value. So depends on, we can assume, but in general overall grayscale value 0 is the minimum. So this formula we can apply for contrast stretching, so that histogram stretching, we can stretch the histogram from 50 to 60 instead of that, maybe 0 to 255 like that. So here also we have very simple formula like what we have applied for histogram sliding. So here you can see this is a histogram or maybe input image I'm taking. Now I have to apply contrast stretching for this input image. Just we can apply this formula. What is the maximum value here? 20. That's why this max is nothing. Sorry, this max is 20. What is the minimum value here? 1. So this minimum is nothing but 1. And max is 255 because 8-bit image. What is the 8-bit image? So 0 to 255. So total number of pixels are 56. So 0 to 2 power 8 minus 1. That's why what is the maximum value? 255. That's why max is 255, minimum is 0, plus minimum 0. So it won't show any effect. So these are the values. So only thing is this f of x value will change according to each pixel value. Suppose if I apply this function for this this pixel value, then f of x is 7. If you apply for this, f of x is 12. If you apply for this pixel, 8. But other values are fixed. So max is fixed 20, f min is fixed 1, max 2255 min 0. All these other values are fixed. Only f of xy will vary, depends on the intensity value of the each pixel. So you can see the explanation. So just we have to substitute all the values accordingly. We can calculate. Finally, the output image will get. Just we can apply these values in the given formula. We can find the each pixel value updated one. And you can see here. So actually, the histogram for this original image is 1 to 20. Now the histogram for the enhanced image is 0 to 148. I think here you can see maximum is 148. We have stretched it. That's why we can call it as a histogram stretching. Instead of 1 to 20, I want to make it as stretching from 0 to 148. That means we are able to find the better contrast value. That's why we can find a little bit better contrast when compared to the original image. So this is very simple formula. Histogram sliding and histogram stretching, we have only one formula. Just we can apply. No need to go for a lengthy algorithm what we have applied for histogram equalization or histogram matching or specification. These two things are very simple. Just a formula that we can apply directly the intensity values. Based on that, we can find updated value and you will get the output image. Then we have stretched from 0 to 148 instead of 1 to 20. Like this. So this is the input image. Let us assume 0 to maybe 10 to 40. After stretching, maybe 5 to 250, like that. So this is stretching across the histogram. We are able to find a little bit better contrast when compared to the input. That is called histogram stretching. So that is the end of histogram processing techniques. Histogram equalization, histogram matching, histogram. Of course, that hands and whatever left I will execute. And histogram matching, histogram sliding, histogram stretching. So this I have explained already. Histogram equalization. Now we can understand what is histogram sliding, and this already explained. And histogram stretching, we are stretched from 0 to 255 instead of 84 to 150 in the image what I have displayed here. And histogram matching also we discussed input image, target image. Based on that, we are able to see better contrast. So up to here, whatever we have covered, at least 2-3 algorithms, we'll try to go for hands-on. After that, we'll come back to the presentation. Up to here, if you have any doubt, we can post our query in the chat box. Now I will move to the hands-on by using Matlab. So, okay, fine. I'll move to the hands-on. So let me go histogram matching. That is main thing what we have covered. The algorithm also not that much easy. So just I will show the execution CLC. We know what is the meaning of CLC. Clear the command window and close all the figures. And let us assume first input image. Let us assume I is the input image. So imread, the name of the input image I am assuming org.jpg. That is the original image I am assuming. And next target image or reference image are equal to imread, the name of the image is ref.jpg reference image. So now we have to apply histogram matching, the b equal to, let us assume, our output. So output equal to, what is the function we have to use for histogram matching? imhist match. Anyhow, if we'll get error also not an issue, we can check it. Yeah, you can see, you can automatically display imhist. We have two parameters. One is input image, comma, one is reference image, or close the bracket and terminated by semicolon. The output image is stored in the variable output one. Now I have to display figure im show output. Title, make it as a matched image or contrast enhanced image. So now let me run this program. So just you can click the run button. So save it as a test. Let us assume 17 is already there, 18 or 19. Text 19, test 19. So Matlab only file. Okay, some error. What is that error? Just have a copy paste in the new editor. So run some text 21. Say some sound I got, some error is there. Figure in show output match image. So error in text 21 line 9. So what is the error in this line? So we can see the output, the histogram matched image stored in the variable output. In output variable, first character is capital O, but here I use small o. That's why we are getting error because case sensitive. Now run this program. Yeah, now are able to see. I think hope you are able to see the output. So we are able to see better contrast enhanced image. So still, if you want more clarity, I have to display input and output image. We'll go for input and output image. Go for directly subplot. One row, two columns. The image position is first one. In show, what is the original image? Capital I. Make it as title. Original image. Terminated by semicolon. Next one. Subplot 1, 2, 2. The image position is 2, comma, in show output. Now we can see here. So hope we are able to see original image having very low contrast. So in enhanced image or matched image, we are able to see better contrast. Hope you are able to see properly now. So original image and matched image. So because the target image having the brightness better, that's why I'm able to get better matched image or maybe output image. Now I'll try to go for some other examples. Maybe I'll go for low contrast. Let me check any low contrast image with me. Low color 2, FDP 70. Low color 2, that is a FDP 70. Any possibilities that now I hope we are able to see original image and enhanced color matched image. So we are able to see properly objects. So because original having low contrast, and what reference image I have used, that also if we want, will let me display that also, so that we are able to see the target image what we have considered. Subplot. In that case, we have to go for 2 rows, 2 columns, because 1 row, 1 column copy. 2 to 1, 2 to 2. Im show. What is the reference image here? Capital R. Title. We can call it as a reference image or target image. Now the match image is 2 to 3. So still one position is vacant, no problem, because it's a 2 by 2 grid we can create. Now we can see here reference image is some medical image I given. So some malaria microscopic image. So but original image is some natural image. But based on the reference image color, so we are getting in the matched image better contrast. So that is the beauty of this histogram matching. So whatever it may be a reference image, it may be natural or medical or whatever it may be, irrespective of image domain. So it will considering the color, or color means the intensity value. Based on that, it will make a map, and we can find a matched image better. So we are able to see better matched image. Based on that, we are able to find the objects of the image properly. So this is called histogram matching or histogram specification. Hope you understood clearly. So with the hands-on and algorithm with numeric examples. If you want to go for, let us say, some FTP 18, some other image if I want to see. So same thing. So here we are not able to see because my reference image is not up to the mark. That's why output image is not good. Maybe FTP 19. So in this case also my reference image also already having low contrast. So that's why matched image having a little bit better contrast, but not up to the mark. Maybe let me take FTP 20. Some random numbers I'm entering because so many images. Yeah. So here also similar to the reference image, we are getting color, but we are able to see some of the objects clearly when compared to the input image. Input image is too low contrast. That's why matched image we can see little bit better. So this is the way we can apply, but when you go for Matlab function, it's very simple, but what is exactly happening, we don't know. That's why I have explained algorithm. So whenever if you are going for image processing, deep learning, machine learning, whatever it may be, first try to understand one algorithm. After that, try to create one numeric example. Then we can go for execution by using Matlab or Python or R programming or Scilab, whatever it may be programming, so that we can understand easily. Suppose if I execute directly in Hist match directly this one, nothing to understand. So maybe you are able to see output. Okay, output is very good by using this Inlist Match. Suppose if someone will ask what is Inlist Match, what is the algorithm, what is exactly happening beyond this, what is the mathematical aspects, all those things. So it is very difficult if you are not understanding properly. That's why always this is the process to learn any algorithm or any concept. So what is the background? First, we suppose if we go for histogram matching, first of all, what is histogram? What is histogram? What is the problem of low contrast? And what is histogram equalization, and how to apply histogram equalization for input image, reference image, and how to do transformation. Finally, you get output image. But these things code directly, everything written inside this function, because this just I'm taking as a function directly, just like a package importing in the Java program, or maybe libraries in the Python. So just in hist and 2 parameters I'm taking. Of course, optionals also there, other parameters. You can go through Inlist Match in the Matlab help command F1. We can find so many other options also. But this is sufficient for us time being. Just we are able to see input output with reference image as a target. So this is fine. Now I'll try to go for histogram sliding. This is very, very simple. So make it as one new. CLC, close all. Let us assume M equal to imread low color dot jpz. So in histogram sliding, nothing to do, just we can add M equal to, or maybe let us assume output equal to, so maybe this I can take it as input. So input equal to imread, output equal to, what is the formula? Input plus offset value. Input plus offset, some value we can assume. Let us assume 60. So now just directly we can show figure in show output, or maybe we can go for subplot 1 to 1 in show output, subplot 1 to 2 in show output. This is output, that is input. I will change these variables. Let me export this one. I will make it as a this slide, just some name. Don't use function names as a program name, because yesterday also we discussed regarding that issue here. Now I think hope you are able to see input image having low contrast. After applying histogram sliding, we are able to see better contrast, but the value is distributed across the image, not like 1 or 2 pixels. It will distribute each and every pixel, just adding value. Maybe if we take low color one, let us assume, I think that image is available in the database. So in this case also, we are able to see the output image, but if you want to increase this, instead of 60, make it as 160. I think we are getting not that much, it's too much contrast, but we are able to see better than. And one more thing you will get out, suppose already input value is 200, if we add 160, then it becomes 360. But is it possible 360 if our 8-bit image? Not possible. So that's why even if the input image value after adding more than 255 also, it will consider as a 255 only. So always the range is 0 to 255. Suppose if we have 200 input value, if we add 500 also, the maximum is 255. Suppose here input value plus I'm trying to add 500. Let us see what happens. See what happens? Nothing. Everything becomes 1, because when you add 500 to input value, all the value pixel values become 255. 255 is nothing but white color. So because of that reason, we got a full white color image. So suppose if I want to make it as a minus 500, then what happens? Everything becomes negative. Everything becomes negative means it will assume it to be 0. That means black image. That also we see. Now you can see full black image only. So that is the reason. So whenever if we take any negative value also, after applying offset value, then it will consider as a 0 only. Whenever if any value exceeding 255 also, it will consider as a 255 only. Don't think 500, 600 like that, because the 8-bit image range is 0 to 255, because 0 to 2 power 8 minus 1 that we have discussed in the first session itself. So this is called histogram sliding. So similarly, we can apply for contrast histogram stretching also. Just we can apply the formula, we can find what is further. So next I'll move to the next concept. So hope you understood. So always try to add minimum value. Don't go for too much value. Don't go for too much negative value also. That's why input plus, let us assume 90 something I'm adding. Now what type of output you'll get? Now we are able to see a better contrast when compared to the input image. So this is called histogram sliding. We can make either left side slide or right side slide by adding positive or negative value. In general, we won't add negative value. Why we have to decrease the contrast? Because our objective is to increase the contrast. So that's why I always try to make it as offset value. That means adding threshold value should be positive. Suppose if you want to test for negative also, I think we have already discussed it. So when you add some negative value, we are getting full black image or maybe less contrast image. So fine, now I'll move to the next one, next concept. I'll come back to the presentation. Still, if you have any queries, you can post your query in the chat box. So similarly, we can apply for contrast histogram stretching formula. So that is end of histogram processing for contrast enhancement. We discussed so many algorithms along with Matlab hands-on with examples. Now we'll go for smoothing linear filters. This we already covered briefly. Now we'll try to complete this also hands-on. So when you come to the smoothing, we already done for nonlinear filters. I hope you remember what are the nonlinear filters: median, max, mean, with hands-on, with mathematical intuitions, everything we have discussed in detail in the second day section of the FDP. So smoothing with linear filters, smoothing with nonlinear filters we have already completed. Smoothing with linear filters also we'll try to come. This is here only one filter, that is called average filter, or we can call it as a mean filter, or we can call it as a low pass filter. So we have to apply average value to the given input image for each size of the kernel, whatever it may be, we are going to consider. Based on that, we can find smoothing of the input image. That means we are trying to reduce the noise. Anyhow, we will see Matlab code also. So this I already explained in yesterday class also, how to apply kernel to the input image, that is called convolution. So just multiply, make sum, just multiply, make sum, that is called response value, that is called convolution. So kernel into star, that is not multiplication, star. So that means K is a kernel star input image is I. So this is called convolution process. After applying convolution process, we can find output value, that is called response variable, that is called response value. So that's why the response is nothing but summation W, Wi, Zi. This is called response. We will see what is the significance of this response. So far we are not discussed the significance of this response for this average filter. Now we will move to that also, how we are going to apply this average filter for smoothing of the given input image. And yeah. So when you come to this, this is a original image, this 3x3 kernel, you can take 3x3 or 5x5 or 7x7. And what is the effect of taking most kernel size also we have discussed in median filter. We used to get a lot of blurring when you are taking 7x7 or 11x11 or 15x15 kernels, that we have already discussed through hands-on also. So that's why I always try to go for less number, maybe, but in research point of, if you are doing any research, don't fix it as a 3x3 is the best. You try to apply 3x3, 5x5, 7x7. After that, you can make a conclusion that 3x3 kernel is giving better contrast or maybe better smoothing when compared to the given other kernels. Like that, we can make a conclusion. You can go for either quantitative evaluation, qualitative evaluation. Based on that, you can make a conclusion, like applying PSNR, SNR, entropy. Then we can make a conclusion. So this kernel we have to apply to the this 3x3, next 3x3, next 3x3, next 3x3. See, it is similar kind of median filter only. Only thing is we have to apply this kernel. This kernel is not having all ones. We have different weights. So that's why we have to make multiply and replace response value by, I mean central pixel value by response. This is the response value. So each central pixel value we have to replace by response. So this is similar to the concept what we have discussed in median filter. Suppose if anyone absent for median filter, median filter concept, just you can go through the recorded session. You can find complete information about this. So the mathematical formula is very simple. Just we have to use convolution process. This is the input image and this is the kernel. Just multiply, make sum, so that we can replace central pixel value by response. So that is the concept what we have discussed so far. So here, when you come to the linear filters for smoothing noise reduction, we can go for a standard average filter like this. So 1/9, all values are 1. This is called standard average linear filter. So when you go for weighted average filter, we can go for this one. Weights are different here. All the weights are equal to 1. This we can call it as a box filter. So we have this question also. So what is box filter? A filter with all equal to 1, not equal to equal value, not only 1, any value. This is called box filter. Whenever all the weights are equal, then we can call it as a box filter. So in standard average filter, so 1/9, why we are taking 1/9? Sum of all the values. So 1/9 into all values are 1. This filter we have to apply to the, this mask we have to apply to the input image and replace central pixel value by average value. And if you are looking for weighted average filter or weighted smoothing linear filter, then we have to use this kernel, this mask. So in this case, the weights are different. So 2, 2, 2, 2. And central pixel is 4, rest of the values are 1. So when you make sum of all the weights, we are getting 60, because we are talking about average filter. That's why sum of all the observations, that is the denominator value, 1/16 into this filter. So each pixel, each 3x3 window in the original matrix, we have to apply this filter. weighted average filter, then we'll get response value. That central pixel we have to replace with response value. So this is called weighted average filter. We can go for standard average filter or weighted average filter, depends on the application. Otherwise both you can apply. So apply standard average filter. What is the image smoothing? So finally you will get what type of output you will get, that you can keep. Again you can apply weighted average filter. Again you can see what type of output you will get. So compare both. You can go for any quantitative evaluation. Then you can say this is the best output image while applying weighted average filter, or maybe this is the best output image when apply standard average filter. Like that we can make a conclusion also. Instead of telling only one filter, apply different kind of filters and we can make a conclusion this is the best one. Based on that we are able to find the better quality of the input image or better smoothing of the input image. So that maybe these weights you can assume according to your convenience also, but these are the standard weighted average 3x3 filter. Suppose if I want to assume here 3, here 3, here 3, here 3, then what happens instead of 16? So plus 3, that means 19 you will get. So one value we are adding for these two. So that means 4 times we added. I mean here 20. Suppose if I want to make it as all ones as 5, let us assume this is 5. Let us assume I want to make it as different weights. So here 5, here 5. So now accordingly, so we are increased here 4, 8. Here we increased 4, 8, 16. So 16 plus 16. So now 32, 1 by 32 into this filter we have to apply. So that's why the weights you can choose accordingly, but this is a standard weighted average mask. But if you want to change according to your application, you can apply. That's not a problem. No need to go for exactly this weighted average filter only. But this is a standard one. We can change according to your application also this one. So I have applied mean filter for the input image, and we are able to see 3x3 what is the smoothing and what is the output, 5x5 what is the output, 7x7 properly. But 7x7 we are able to find some blurring. That's why in general don't go for mask or kernel with more sizes. Because of that reason we are able to see this type of blurring in the input images. That's why always my suggestion try to go for 3x3, 5x5. Maybe you can apply 7x7, but after that we can go for any quantitative evaluation. Based on that we can make a conclusion. So the image smoothing is better when you apply 3x3 kernel or maybe 5x5 kernel. Like that we can make a conclusion. So that it's clarity for everyone. Even I am a reviewer for your research article. It's a full clarity for me. Otherwise, I'll get confusion. So how we decided and what basis? Why can't others kernel sizes? Like that, obviously, you'll get so many review questions while you are receiving the comments from the reviewer. Maybe same comments maybe you'll receive from all the reviewers also, because there is ambiguity while judging this type of output images. So now I'll move to the Matlab hands-on. So here this is very simple. Just we have noisy image, some noisy image I'm assuming. We have to convert it into grayscale image. So RGB to gray. Of course, we can go for color images also. What is the logic? If you want to apply color images, each channel we have to extract. After that, we have to apply filter. Then we can combine by using cat function. We'll get output image. So that's why always why we are converting RGB to grayscale image. When you are converting RGB to grayscale image, we are able to see a single channel processing instead of 3 channels. Because if you go for color image, we have to go for 3 channels. That is called RGB. Suppose if you want to make it as a grayscale image, then we can look for a single channel. Just a second. So here what we have to do, sorry. So we have to here we have to create average filter. So average, that is the key. This is actually a special is a function. By using that we can create an average filter. and this is the keyword. We can go for average or maybe Gaussian, Laplacian, log, depends on the filter what we are creating. That keyword we have to write. So this is a fixed. We can go for either average filter, or you can go for Gaussian filter, or you can go for Laplacian, or you can go for log, etc. But we are talking about average filter. That's why we have to create an average filter. What is the size of the average filter? 3 cross 3. So that means our aim is to apply average filter to the input image. For that we have to apply, use the function that is called infilter. So H is a average filter. This we have to apply to the input image Y. So try to understand. Here we don't have direct function like immid or maybe median filter what we have discussed. So we have to go for two things. One is we have to create an average filter of kernel size is 3 cross 3 or mask size, or if you want to change 5 cross 5 also fine. If you are not specified, I think by default it will take 3 cross 3. So here make it as a 5 cross 5 or 3 cross 3, your convenience. And once if we create an average filter, this we have to apply to the input image. For that we have to go for imfilter. So that is a Matlab function, imfilter. So by using that we can apply the average filter to the input image Y. We have two parameters. So one parameter Y is nothing but input image, H is nothing but average filter. This we have to apply to the Y. So same thing, if you are looking for Gaussian filter, replace average by Gaussian. Or if you are looking for Laplacian filter, replace average by Laplacian. Or if you are looking for log filter, replace average by log. Or if you are looking for circular average filter, replace average by disk. Like that we have various options. So if you want to details, complete details, you can press F1 and type S special in the search button. We can find complete details about S special function. So that we can understand what is the meaning of F special, how to create average filter, other filters also. So this is a simple Matlab function. So Matlab code for executing the average filter. So you can see original image, we have a lot of noise, but mean filtered image not up to the mark. We are not getting that much encourageable output. And here also we have a lot of noise in the input image. When you apply average filter, median filter having better noise reduction, especially salt and pepper noise reduction. So that's why in general we'll go for this non-linear filter for salt and pepper noise. So original image. So when you see the original image, we are able to see a lot of salt and pepper noise. When you see average filter, median filter, here we are finding better quality when compared to this image. So we have contrast. Limited CLA HA, one more technique is there. So this no time to explain. Here what we have to do is, so here mainly we are focusing on for small sub images. For that we have to apply histogram equalization. That is the concept here. So it will take time to explain this completely. So you can see the entire image is divided into small parts, small regions. After that we have to apply histogram equalization. So but the Matlab function is very simple. Just we can apply adopt hist eq. So this is a simple Matlab function. Adopt HISTEQ. This is the histogram equalization Matlab function. Just we have to prefix with adopt. So that is called adaptive histogram equalization. That's the meaning. So based on that we can apply to that. But here the basic idea is we are applying for sub images. So you can see original image. After that we divide in. We are applying here histogram equalization. So finally we can find the enhanced image. So that complete details you can go through that algorithm. I will not explain because it will take a lot of time. So just I want to compare. So original image, histogram equalization image, and CLA HA. So by using that we are, but here we are not getting that much quality image when compared to the histogram equalization for this example. In this example, okay, better. So histogram equalization, CLA HA both we are getting, that is called histogram equalization, and CLA HA both we are getting better quality, not an issue. So now one more thing is that is called imwrite. So imwrite Matlab function is easy to write some output image in the required place, wherever it may be, some folder if you want to write. Suppose I have an image A and I want to I want to save this image in some folder. So for that we can go for imwrite. Let us assume after converting RGB to grayscale image, so directly if we want to store that image in my some folder, then we can go for what is the standard format imwrite. We have two parameters. One is variable, image variable, and one is the location of the folder where we have to store. For example, C drive, users, admin, desktop. So the name of the image is new.jpg, like that. So we have to go for two parameters. One is image data A, that is the output image where we are looking for saving, and next one is file name. We have to specify the file name. So including drive followed by any other folders are available. Based on that, it will save. Suppose directly if you want to go for E folder, then we can go for imwrite directly A, comma A is the image, the whatever image stored in here that we are going to write in the folder. Let us assume C. So just single quote C, then it will store automatically. Or maybe C is to, let us assume users I want to store. So maybe we can C slash the image name we have to give new dot something JPG. Anyhow, I will show hands on also this one. So you can see, so the image is new.jpg in desktop. So I want to write this in desktop. I want to save this in desktop. That's why in desktop new. Suppose here new1.jpg. So here new1.jpg. The images are written, or we have to store, or we have to save it in the desktop by using imwrite function. That is called imwrite Matlab function with two parameters. One is nothing but image, and one is nothing but location of the image, where we have to store that image. So image segmentation. So, now this will try to complete. After that, I'll come to the image segmentation. Whatever we completed, that we'll see hands-on. That is called average filter. Whatever we have done, that hands-on will try to complete. Then I'll move to the image segmentation. So just I'll move a little bit past this one. So here. Average filter, this code is already have written, so no need to type. So I have already told you we have to create an average filter by using f special function with the specified kernel 3x3 size, and after that we have to apply this average filter to the input image by using imFilter. Now I will execute this one. Just we have to run the code. So mean filtered image, so that is not up to that quality. So original image, mean filtered image. When you execute this one once again, so original image is figure 2, figure 1 is nothing but original image, and figure 2 is nothing but mean filtered image. So of course we reduce the noise, not that much encourageable when compared to the median filter. In median filter we are able to reduce lot of salt and pepper noise, but in this case, so we are not able to reduce much noise when compared to the input image. So maybe let me try some other noise image. So which image I can consider here? Just I check it in the folder. Let us assume. Noise. So image name is noise, NOISC. So just I will use this image as it is. So let me run this program. So here also same issue. Better, okay, not that much good when compared to the median filter. So original image having lot of noise. After applying mean filtered, we are getting some output, but not that much good quality image, noise reduction image. Maybe if I'm trying to change the size of the mask, so instead of 3x3, maybe make it as 5x5. So in this case, also a little bit better than 3x3, especially in this case. So this is the original image, and this is the filtered image after applying average filter. Maybe you can apply, just replace average by Gaussian like other keywords, GAUSSEAN, Gaussian filter. I'm not explained mathematically, but just let me try this one, Gaussian. Yeah, you are able to see this one. So Gaussian filter, this is a worse than mean filter. You can find almost same output image, input image only we are getting here. This is not good for these images. So maybe it may be good for other images, but for this case, so we are not getting better quality. So that is the average filter. What else left? imWrite. So imWrite, let me take even CLA-HE also available here. So adaptive histogram equalization, contrast limited adaptive histogram equalization. Directly I'm executing. Here the simple function is adopt histogram equalization. So histogram equalization is EQ function directly we can use. So let me execute this one. Yeah. So you can see the output image. So I have executed by using histogram equalization along with contrast a limited adaptive histogram equalization. Both I applied. So I think histogram equalization having better contrast here when compared to CLA-HE. Yeah, so fine. So now I'll move to the presentation. So next one is image segmentation. So So this is also vast topic, but anyhow, I'll do the basics. So image segmentation basically, for example, let us assume, I'll give a very simple example. So this is the image. So we have vegetables or maybe fruits, let us assume like this. So maybe I'm looking for only vegetables. I want to segment, so vegetables only, or I want to segments only, fruits only. So this is what we are going to do here. So segmentation means divides the image into group of pixels. So each group of pixels having some similarity. Maybe let us assume when you let us assume this is the image. I want to make it as a, so two segmentation. This is one segmentation. Let us assume vegetables. This is one segmentation. Let us assume fruits. So these vegetables having a similarity of pixels, maybe color same. That's why we have a similarity of the pixel. That means some property satisfied. Fruits having some property. So because of color value, maybe let us assume here vegetables, here we have fruits, here we have, let us assume benches, or maybe something other items, other objectives. So let us assume benches. So we have three objects, three binary segmentation. So the image is segmented into three meaningful regions. So V, F, B, like this. So this is the basic idea beyond the segmentation. Segmentation is the process of divide the given image into meaningful regions. So each region having its own properties. So based on that, even when you go for medical application, let us assume this is the input image, and we can segment this image as a, let us assume like this. So here COVID-19 infected cells, or maybe cancerous cells. So like this we have other cells not infected with cancer. That's why only these cells are segmented as a cancerous infected cells. So based on that, doctor will go for further diagnosis. So like that, we have huge number of applications of image segmentation. I will show some of the segmentation applications. Based on that, we can understand the significance of image segmentation. So this mathematical aspects, leave it. Just the meaning of this mathematical aspects is when you divide meaningful regions, let us assume. So I have to divide, let us assume R1, R2, like that. So let us assume R1, R2. I want to make it as a specific to three regions. So when you combine all the three regions, you will get original image. That's the meaning of this first. So if you go for generic I to N regions. Next, each region is connected, obviously, and intersection of R1, R2, vice versa, or maybe R2, R3, there is no common element, that's why empty. And P of R is 2. So if we take predicate, P means predicate. So predicate, that means there is a condition for each region. That means some condition should be satisfied for each region. So that's why the predicate is 2. Next, when you go for union of R1, union Rj, it is false always. The predicate of R1 and R2, if we include, the properties are different. So how can I combine infected region and uninfected region? Based on that, how can you look for same property? It's impossible. The color values are different from infected region. The color values of uninfected region, both are different. That's why predicate of R1 union Rj is always false. That is the meaning of these mathematical notations. But hope you understood what is the concept of segmentation. That is fine. No need to worry about these mathematical aspects, what I have explained. Here we require some discrete mathematical structures, concepts like predicate, all those things. So if we take here medical application, so we have a brain, so brain tumor, we can go for segmented like this. So immediately doctor will say, so this area having brain tumor, we can go for further diagnosis, like that he will say immediately. Maybe number plate recognition. So just by using segmentation, so because anyone violating the traffic signal, so immediately the camera will capture, and after that we'll get notice. So the automatically the segmentation technique will recognize the number plate, it will segment, and based on that number, it will match with the address, then it will send the notice to the respective violator. And we have various segmentation, discontinuity of detection, gray level similarity, and isolated point detection. When you have image, we have to go for isolated point, or maybe when you go for image, we have to go for line detection. When you go for images, we can go for edge detection. And gray level similarity, based on the similarity of each region, we can apply either thresholding technique or region growing. We have to fix some seed value, and we have to go for seed criteria, that is called seed growing criteria, that is called region growing. And region splitting merging, we have to split the region into image into various regions. After that, we have to merge based on the property, because just for explaining these things only I required 4 to 5 hours. That many hours we required for these concepts, but just I'm giving brief idea, so we don't have time to explain all those things, but just I'm showing these are the various segmentation techniques. So but each one is one research area. Suppose if you go for edge detection, that is one research area. For maybe again you can choose either medical field or maybe other application. Thresholding, maybe there we can find huge number of research. Region growing, region splitting and merging. Region splitting and merging is like the divide and conquer technique. We have to to divide. After that, we have to compute. Same thing here also. We have to split the given image by using some criteria, that is called by using some predicate. After that, we have to merge the regions by using some predicate. Finally, we have to go for number of segmented areas in the given input image. So these are the basic ideas. Maybe in free time we can go through each concept. It is a too vast topic. That's why I said it will require 4 to 5 hours to complete this all the techniques whatever I displayed in the segmentation. So this is point detection. Just this is the edge detections. So here we are able to find the edges of the original images and boundaries of the medical images we have to detect. Based on that, we can identify what is the width, length, all those things. Based on that, we can decide what is the status, what is the stage of the cancerous, whether you are in initial stage or maybe final stage. Like that, we are able to decide easily by using this segmentation. And the thresholding is one of the simple segmentation technique. By using threshold value, we can divide. What does it mean here? Suppose we have an input image like this. Suppose I have to take input value as a threshold value is 6. So let us assume the input pixel values. Let us assume f of xy whenever greater than or equal to 60. So threshold value, make it as 1. Otherwise, make it as a 0. So the 1 means white color, 0 means black. So finally, wherever if you find 1, that is that object what we are looking. 0 means that is not we are looking. Suppose if we take what is the threshold value for university exam, 35. Whenever student got greater than or equal to 35, we can make it as a segmented as a pass. Otherwise, we can segment it as a fail. That is the meaning of threshold. So threshold value is fixed, or it may be vary, depends on the images. So here, if we take university exam, 35 is the threshold value. More than or equal to 35 means pass. Otherwise, we can make it as a fail. Similarly here. So let us assume these are the pixels having more than or equal to 60. So this is the one region, and these are the region which is not having more than or equal to 60. Make it as R2. So this is the reason what I am looking. So based on that, we can say this is infected with malaria or dengue, like that. So that is the basic idea of threshold value. The entire histogram we have to divide it into 2 parts. So one is this is the region which we are not looking. This is the region which I am looking. So greater than or equal to threshold value means infected region. Less than threshold value means not infected region. Or maybe if you want to assume vice versa also fine. Depends on the application. So you can see the mathematical equation, very simple mathematical equation. So output image g of xy equal to 1. If the input image pixel value greater than 3 or maybe greater than or equal to 3, you can assume. If we assume greater than or equal to 3, then you can assume less than here. So 0, less than or equal to t. So this is a simple image thresholding formula. This we can call it as a global thresholding. We have to fix. Of course, we have some issues also for fixing. For that, we can go for Woods thresholding or maybe iterative thresholding technique. Like that, we have our hybrid thresholding techniques. Like that, we have various thresholding techniques. By using that also, we can fix the thresholding value. I will show some of my research articles on this thresholding technique also as a research directions. So this I will skip. So here you can see this is the input image, and I am assuming threshold value 100. So more than or equal, more than 100 means 1, otherwise make it as 0. Finally, this is one reason, this is one reason. We have segmented the given input image in 2 reasons. So this is the reason all the students pass, this is the reason all the students fail, like this. So this is the reason infected with cancer, this is the reason not infected with the cancer. That's the meaning of this thresholding output image of segmentation. So original image, thresholded image. By using some threshold value, we can extract, we can segment the given objects. Maybe like this here also we can segment. And fingerprint recognition also. So when you put fingerprint for biometric attendance calculation, so you can segment this input output image we have got here. And for segmentation by for healthcare applications. So this is the input image. After applying threshold value, we are able to find the infected cells. So of course, threshold value, it's not constant, it may vary. Suppose if I take t equal to 0, nothing, I got output. Suppose if I take t equal to 10, I'm getting a partial output. If I take t equal to 25, I'm able to see better. When I take t equal to 75, I'm able to see object properly. When I take t equal to 155, this is not up to the mark. Like that, we have to look for various threshold values. Based on that, we can fix the final threshold. If we take a Matlab code, it's very simple. We have to go for here nested for loop. One for loop for rows, one for loop for column, because image is nothing but rows and columns combination. So whenever the pixel value is greater than or equal to threshold value, make it as 1. Otherwise, make it as 0. End of out if statement, end of inner for loop, end of outer for loop. So the Matlab code is very simple. Just we have to use for loop. We have to take each and every intensity value, that is called pixel value. If the pixel value more than or equal to threshold value, make it as 1. That is stored in the binary image. That is the variable. Otherwise, make it as 0. if you take this medical image application, original image after segmented image, we are able to see infected cells. Same thing here also, infected cells we are able to see, and segmented objects. And coming to the research directions, so this is my paper published in Elsewhere journal. So before going to that, I'll execute the threshold. After that, I'll come back to the research direction. Just a minute. Yeah. So here I have already done threshold. So this is the same code I have explained already just now. So here we can see for loop. Just we have to use nested for loop, and we have to consider each pixel value. If the pixel value more than threshold, make it as 1. Otherwise, make it as a 0. 1 means the object what we are looking. 0 means background. No need to look for that. Foreground, background like this. So just execute this program. Just I'm fixing threshold is 120 here. So you are able to see segmented image like that. So we are able to see this kidney spot something here. So this chest X-ray image, we are able to find the output properly. And suppose if we go for some FDP16, some other image, yeah, so we are not able to detect exactly the brain tumor. Maybe if we take some other image, so that's why depends on the threshold, it may vary. Suppose I'm taking FDP13, that image name is FDP13, that is called malaria microscopic image. So yeah, we are able to find, you can see little bit infected malaria infected we are able to find here. So otherwise make it as threshold value 90 instead of 120. And now still I'm not able to find properly. Make it as a 50, otherwise not able to find. Otherwise make it as some other threshold value. Yeah, now we are able to see the infected small area infected with malaria. That portion I am able to see as a black color. Or if you want to make it as white color, we can go accordingly. Suppose if I want to make it as white color, we can make it as less than or equal to. Let us assume. Then we can make it as a, yeah, you can see black color is background, white color is infected malaria infected cells. Maybe instead of 150, make it as 190 otherwise. Now we are able to see, so the cells infected with malaria, but some of the cells not infected also we are displaying, but we are able to see some segmentation of the infected cells. So the threshold value choosing only for problem. For that we can go for some of the automatic threshold value selections, that is called iterative thresholding technique, or food thresholding, or hybrid thresholding. Like that we have maybe multi-step thresholding methods. Like that we have various thresholding techniques. By using that we can choose accurate thresholding. Based on that we can go for segmentation. So manually we can't fix. So if you fix means it may work out for maybe 1 or 2 images, but not for all images. So this is some of the research directions. These are the papers published, and you can see I am the first author for this. A novel 2-stage thresholding method for segmentation of malaria images. That is the microscopic malaria images. So here it is very difficult to go for a single thresholding. That's why I'm using 2 stages. First stage I have fixed this thresholding, and next I have fixed this thresholding by using iterative or max entropy thresholding. Based on that we are able to see proper outputs. You can see now, so input images, output images. The infected cells we are able to see properly in the output images. The infected malaria infected cells are able to segment properly. Based on that we can go for further diagnosis. This I will skip. Of course, edit detection is there. Just I'm skipping this one because even morphological operations. Even this is one more article that is published in Elsewhere journal, Computers and Electrical Engineering. I think this is having more than 3 or more than 4 impact factor with SCA indexed journal. So almost 1 year took for evaluation only. So here I done a segmentation of infected areas. So the complete procedure here, illumination correction, noise reduction, and FCM method, connected component, MPP method. Like that we can go through this paper. You can find complete information about segmentation of infected cells of malaria. That is available in online also. So why I'm showing here segmentation having that much impact for medical imaging or maybe other applications also. We are able to see infected cells properly, and based on that we can go for further diagnosis. And I have compared with various other segmentation techniques. Based on that I concluded that my segmentation method yields better results when compared to other segmentation. So otherwise simply I can't say, but these are the standard segmentation techniques. Of course so many authors proposed other segmentation techniques also. These are the standard segmentation techniques. Based on that I can make a conclusion my segmentation is giving better results for these input images, like medical microscopic images for malaria diagnosis, like that. And machine learning image analysis for COVID-19. So here also we require image processing concepts for pre-processing all those things for chest X-ray images. So here we apply deep learning technique for classification of the COVID-19 images. You can go through this paper that is available in Elsewhere journal. So that was my talk. So if you are looking for additional resources for image processing and Matlab, so I already mentioned about these are the standard textbooks for further enhancement of image processing as well as Matlab. So that was my talk. So thank you all the participants. So if you have any queries, you can ask me or you can send mail also. So in free time, surely I like to reply to the mail. So even I have also hit schedule, but whenever free, surely I'll reply to your mail. So if you have any questions, you can put your queries in the chat box or you can unmute and ask me. I'm happy to answer your query. Still, so many concepts are there. I already mentioned. So it's a huge subject, but I have explained all the basics, fundamentals with Matlab. You can go through that. That will give a path for learning rest of the Matlab and rest of the image processing techniques. No queries. If you have any queries, you can put in the chat box or you can unmute and ask me. Or you can share your queries or maybe suggestions to the mail ID. Here you can see jshomesek@gmail.com. So, but surely I'll give reply. Maybe it may take time sometimes because of my schedules also enough. So thank you all the participants for your support and cooperation and properly responded for all the sessions. And thanks to organization for the opportunity. Thank you one and all.
Thank you so much, sir.
Welcome.
As we've come to the end of the event, I would like to take a moment to express my gratitude to all of you for joining us today. I would like to express my sincere thanks to our keynote speaker, Dr. J. Somashekar, who have made this event such a success. Contribution have helped us create a valuable learning experience for all the attendees. Before we wind up, let me give you an update on our upcoming events. Third International Conference on Engineering, Social Science and Humanities, ICESSU, which is held on 30th and 31st March 2023 in Manila and Manila. And the next conference will be International Conference on Recent Advances in Technology, Engineering, Science and Management. It is held on 16th and 17th March in Mumbai, India. And next is the fourth International Conference on Multidisciplinary and Current Education Research, ICMCER. It is held in Bangkok, Thailand on 11th and 12th of April. And the last one is the International Conference on Multidisciplinary Research Studies in Education, ICMGRSC, held in Malaysia on 19th and 20th May. On behalf of IFERP, I would like to extend my heartfelt gratitude to all of you for attending our FTP over the last 5 days. Our attendees' participation in question and answer session and networking events was very impressive. Thrilled that we were able to foster an environment that encouraged collaboration and knowledge sharing. Success of this event would not have been possible without your participation, support, and contribution. We are thrilled to have had the opportunity to host such an incredible group of individuals, and we're honored that you chose to spend your time with us. Finally, we would love to hear your feedback. Your input is valuable to us, and it will help us to improve future webinars. We'll be distributing feedback forms to your emails. So please take a few moments of your time to fill them out, and your certificate of participation will be distributed to your membership dashboard. Kindly log into your account and download the certificate yourself. Thank you all once again for your participation and contribution to the success of this event. We hope to see you all again. Thank you all.